Okay, so welcome to today's lesson where I'll be looking at balancing chemical equations. So far we've done a lot of videos on how to write a chemical equation, how to identify the type of chemical equation. So today our primary focus is simply on balancing chemical equations. So the first rule or the first tip that you should always bear in mind when you are dealing with a chemical equation is that the number of atoms on the reactant side must always be the same with the number of atoms on the product side. So always the number of atoms on the reactant side must be the same with the number of atoms that are on the product side. So what this means is that every reaction has two sides. There's the reactant side and the product side. So every atom that is found here, every single atom that is found on the reactant side must also be found on the product side. And the number of atoms that are found on the reactant side must also be the same number of atoms that are here. So here we should always make sure that on the product side there is no new atom that should be introduced. Whatever you start with must always appear here, and you shouldn't gain or lose an atom here. Don't introduce an atom. So if you started with say 2 atoms of whatever that element is or compound is, must also be reflected here, the same number and the same type of elements involved. So this is what we're going to look at. Now we are going to have the first example, and the first example here is you have magnesium oxide that is reacting with hydrochloric acid to produce magnesium chloride and water. So this side is the reactant side. This is the reactant side, and this is where we find the products, what has been produced from those compounds that are reacting. So we have two products that have been produced from this reaction. Now we need to account for all the elements that are here on the reactant side, and we must also account for all the elements that are here. So what is here is that any element that is here, so here we have magnesium, we must make sure that magnesium is also found this side. So oxygen is here on the reactant side, we must ensure that it is also found on the product side. You have hydrogen here, we must ensure that there is also hydrogen on the other side. There is chlorine here, we must ensure that on the product side there is chlorine. If for whatever reason what you have on the product side here, then there is a new element that has been introduced, then you must know that there's a problem with that chemical equation that you are looking at. So now, after establishing that, we need now to start finding answers. How do we balance this chemical equation? Now, balancing chemical equation is very simple. All what you need to do is to come up with elements. So this tabular kind of arrangement will help you analyze what is involved. So firstly you have magnesium. So magnesium here, you must count how many you have. Then what is the next element? You have oxygen, then you have hydrogen, then you have chlorine, then you move. So exactly what you have here, so chlorine should come here at the bottom. So exactly what you have on the product side must also appear here. So you can just I transfer all those elements there. The next one is oxygen, so that it's easy for you to analyze. So I want you to pay particular attention so that you don't miss a thing. So when balancing chemical equations, we are simply adding coefficients. Do not break a compound. We are simply adding coefficients. Coefficients are numbers that are put before a particular variable. So that number, it has to be put either here, here, there, or there. Okay. So now let us try to account now how many atoms of magnesium do we have on the reactant side. So here it's not about guessing or what. You have to pay particular attention, and what you are seeing is what is happening. So there is nothing like guessing. So magnesium, how many? So here what is seen? There's only one. So you have one atom of magnesium. What about oxygen? How many atoms of oxygen are visible there? Not what you think or what you are imagining, but how many are you actually seeing there? So you notice that you have how many? One. Then again you move to hydrogen. How many atoms of hydrogen are you seeing there? So you notice that you have one atom of hydrogen. Then you continue moving to chlorine. How many atoms of chlorine do you have? So you notice that you have one. So here, all the atoms that we have one atom of each element involved on the reactant side. What about the product side? So you do the same. So how many atoms of magnesium are you seeing here? So from what is here, you notice that you only have one atom of magnesium. Then you move to oxygen. How many atoms of oxygen are there? You have, I think if you said one, then we are on the same page. Then what about hydrogen? How many atoms of hydrogen are here? So you will notice that on hydrogen there's a number, a base there, a 2. So this 2, once you see any number that is smaller here as a base, it only belongs to the element that is just before that number. So this 2 is for hydrogen. So it simply means that here there are 2 atoms of hydrogen. So this 2 does not affect the number that is on the other side, This number is only for the particular element that is before it. So now here we are going to say how many atoms we have? 2. What about chlorine? So the exact same explanation that I gave here. So here you have magnesium, then chlorine. So before this number here 2, which is a base for chlorine, this 2 does not affect magnesium. It is only for chlorine. So we are going to say we have 2 atoms of chlorine. Now, once you are able to analyze this, the only next step now is to try and compare. Do you have the same number of atoms on the reactant side and the product side? As we said on our first statement there is that we must have the same number of atoms. So yes, let's see. Magnesium here, 1. What about there? We have 1. Okay, this one is okay. Then here we have oxygen. How many atoms? 1. On the product side, how many atoms of oxygen? 1. So this one is also okay. Then here you are going to now move on to hydrogen. Hydrogen, how many atoms are there? You have 1. What about this side? We have 2. And where is hydrogen? Hydrogen is here. And this hydrogen is also bonded to chlorine. So from what we are seeing here, on the product side, we have 2 atoms of chlorine and 2 atoms of hydrogen. So now, for us to ensure that this equation is balanced, we have to add the smallest number that will help us ensure that we have the same number of atoms here on the reactant side and product side. So if you start with 1, so here 1 does not make any difference because we are not adding. So we're going to say, okay, so when you add a 2 there, then the whole scenario changes. So what we are going to have now is that on the reactant side you have how many atoms? So this 2 is a coefficient. It is multiplying everything that is on the other side. So you're going to have how many atoms? So here you have 2. How many atoms of chlorine? You're going to have how many? 2 now. So when you compare, you realize that here you have 2 atoms of chlorine, 2 atoms of chlorine, 2 atoms of hydrogen, and 2 atoms of hydrogen. So now you can conclude by saying magnesium oxide, when reacted with HCl, will produce magnesium chloride and water. So the equation now is balanced. So your equation is completely balanced. So we'll be showing you another example in the next video.